That will be presented by Wim Stevels from Eastman. Wim is responsible for the technical support for Saflex and Van Seva interlayers in architectural glazing. And he works from the Netherlands. Besides that, he's also involved in several national and international standardization committees on laminated glass. And as I said, Wim will present on how to reduce embodied carbon for interlayers.
Thanks very much, Christian. Yeah, now it's working. And thank you, audience, for making it out here at this early hour in the rain. Really appreciate it. Maybe there are some people coming in, but you are the early birds, and that's really appreciated. As Christian said, I'm Wim Stevels. I work at Eastman, making interlayers. And right off the bat, I want to mention and thank my co-authors on this presentation, Barbara Meunier and Bart de Bruiker. Barbara is actually here. She's sitting in front. Very well done. And she may join in at the Q&A towards the end. The title of my talk is How Interlayers Can Contribute to Reducing the Embodied Carbon of Glazed Facades of Laminate Glass Elements. That's a very long title, and it's already an indication that in and of itself, interlayers are only a minor part of the facade, having limited mass. So the contribution is not really big. Nevertheless, we feel it's important to reduce what we bring to the market, and that's also asked to us of the value chain partners. Christian, could you check if we can run the monitor up front? That would be nice. So if you don't know interlayers or you don't know Saflex and Van Seva, these are safety interlayers. They provide safe breakage characteristics to laminated glass. They have been on the market for a long time. Most of the time, you don't see them. So in a way, they are an invincible solution. And over time, many other functionalities have been added. The most prominent in the market today is acoustic interlayers, and you can see all of the other functionalities that are listed on the slides. So short message, there's a huge variety of interlayers, even within PVB interlayers today. So let's go to an overview of this presentation. A few introductory words why embodied carbon is important. In the first place, we'll have a look at how those values are generated and understand a little bit more about the sources of the data, specific data versus database values, and also they can differ interlayer product to interlayer product. And once we have this baseline established, we can have a look at how you can improve the carbon footprint either through products or smart glazing design. And finally, we'll touch upon what we do in the circularity area as a nice lead-in to some of the other presentations later this session. So with that, why is reducing embodied carbon important? Widely cited number is that 37% of global emissions are associated with building and construction industry. And the interesting thing is there's a part of the carbon that is consumed in the operation of the building, operational carbon that can be heating, cooling, providing functionality to the building with like all the wonderful lighting in this arena. And you have embodied carbon, all of the materials and emissions that went into creating building structures. And as our buildings get more energy efficient, as we are decarbonizing our grid, the fraction, the relative importance of embodied carbon is only expected to increase. So where do we play as a manufacturer of materials? Well, that's mainly on the left side of the entire stages of a building in a product stage. That's where the materials are created, where they are processed. Some contributions in the construction stage to transport, but it's relatively minor. Almost none at all in the operational phase. The materials are just there and do their function. And then finally, we can also make a contribution towards end of life, trying to reuse as much materials as possible. So again, laminated interlayers provide safety to glass. It's a small foil, an adhesive on a roll, if you will, between two pieces of glass. And when the glass breaks, the shards stick together and they can't injure people. That's the primary function. And if you look at a typical configuration, the glass is always much thicker than the interlayer. This is a very common configurations, 4 millimeter of glass, 0.76 millimeter of interlayer, which is a standard thickness of interlayers, 4 millimeters of glass. And if you look at such a product, about 13% of the embodied carbon in a laminated glass can be attributed to the interlayer. Of course, the glass could be 10 millimeters, it could be 15, the interlayer could be thicker. So there's a lot of variations to that, but just for this reference configuration, it's around 13%. It's also important to think about what the source of the embodied carbon is, because glass itself has almost no carbon content as a physical carbon atom in the glass. All of the embodied carbon comes through processing of the glass. Well, not all of it, but certainly a glass is a very high melting material and the energy consumption to produce glass is very high. In contrast, in an interlayer, it's a carbon-based material, and most of the carbon comprised is not from the processing, but it's in the actual material itself. So at this stage, it's not lost at carbon dioxide. It could be recycled at some point. So that's the big difference between glass and interlayers when it comes to the source of embodied carbon. And with that, we're now ready to look at some values. Values for embodied carbon or carbon footprint are established to life cycle assessment or life cycle analysis. There are standards related to that. And if you look at the PVB product, you can find a variety of values out there. Now, I've taken a typical value from a guidance document from the UK CWCT guidance document on how to calculate embodied carbon in facades. And we find a value of approximately 2.7 kilos of carbon dioxide equivalent per square meter for a 0.38 millimeter interlayer. However, when we look at our actual inputs, our energy consumption, bring that into an LCA and have that third party verified, we found a much lower value. And it's understandable that database and guidance values are conservative by nature, but that means that for a facade engineer, they can get much more accurate values using the actual value, whereas the difference on the interlayer value is really high, almost 1/3. Even it already translates to an 8% reduction using a specific value for the laminated glass itself. As we've seen early on, there are many PVB products out there today, and it makes sense that these come with different footprints. We have done the work and mapped that for our portfolio, so it's not an aggregate value just all across the board. These are specific values for each interlayer that we bring into the market. And it also specifies the methods how these data were collected, which standards were used, which time frame with software. So that makes the values also transparent in a sense. So now we have that baseline, and now we can look at improving the values. And what we found in talking to our customers, in talking to the market that compromises on quality or performance are basically not accepted today. So for speed of adoption, we had to stick to the current specifications of interlayer materials, and that goes both for the aesthetics and for the safety and security performance. Of course, that alleviates a lot of the pressure from external requalifications, but it's also a constraint in what we can do. We looked at what can we do, and here we see our levers. Of course, we're looking at our process to be efficient, to have a high yield. We look at our sourcing, both for raw materials and energy. And we also increased the PVB content, the recycled PVB content in a physical way, staying within the quality boundaries, and had that LCA, the resulting LCA, third-party verified. We took that a step further because in itself an LCA is really not enough, because there's a lot of ways in terms of scope, in terms of methods we could that are used out there, and move that to an EPD or environmental product declaration, which is it does two things. It extends the scope to comprise the full cycle, and secondly, there is a specific set on how to calculate values or product category rules, and that makes it possible to compare one value to the other. It also makes it more or less plug and play for our direct customers and the end users in the market, because you can take the value from the EPD, put it in your EPD for laminated glass, put it in your EPD for the glazing as a whole, and ultimately to the facade. So with that, let's look at what was achieved, and focusing at the bottom part for the moment, the interlayer part. You see the two numbers that I shown before, the database value, the specific PVB value, and then finally the reduced carbon PVB interlayer that we were able to develop in this way. It's called Saflex Light Carbon Clear. And what you see is that the carbon footprint is now reduced to 1.2 kilos of carbon dioxide equivalent per square meter. And if you think about what I said in the beginning, that carbon is still there. It could be recovered at the end. Now, it makes sense to use such a product with a low carbon glass, because glass is still the major part of the laminate. And when you make those choices, you can go from a value using standard float glass with a database value of PVB at around 29 kilos of carbon dioxide equivalent, all the way down to around 16 kilos. That's a reduction of 44% by making these conscious choices. As I also said earlier, it will vary configuration to configuration, and that's why we developed a calculator. It's available online, really simple inputs. In the end, you can download the results for the laminated glass and make comparisons depending on the choices that you make. So that's the product development part. Not for us, but for the larger community, smart design is also very important. And one can use, for instance, stiffer interlayers to help reduce embodied carbon as well. And I've generated an example here using a stiff interlayer, Saflex structural, in a cantilevered balustrade. Now, let's say that the original configuration is 10-10-2 in annealed float, around 60 kilos carbon dioxide equivalent. And you can reduce that while retaining the mechanical properties to around 50 by using a stiff interlayer. How do we know that the mechanical properties are retained? Well, the effective thickness, and I won't go into detail here. For this particular load scenario, for the two products is more or less comparable, so the laminates will behave in a comparative way. The other thing one could do is get even more creative, a little bit more out there. Two examples of projects that were featured recently on GlassTech: a self-standing structure with laminated fittings, where you avoid all of the structural steel and the loads are transferred to the laminated fittings. And basically that concept was extended and improved to produce part of a glass dome, also with laminated fittings, linear fittings in this case, and the simple laminates on the left were replaced by a full IGU. And there's documentation out there to show some of the engineering thoughts that went into that. On circularity, what we are doing, what we are increasingly doing and have been doing, is use our customers' waste materials to generate new PVB through a trim return program. That's scaled up. We've also seen that the prices have gone up, so that must be working. So that's a good thing. Where we spend most of our research effort today is to enable reuse of PVB that has touched glass. And there are two levels of that. One is laminates at our customer that somehow can't go to the market. We know that that PVB is relatively clean. We know what it is. Our customer knows what it is. That's a source of PVB that could be reused. Our customers are interested in reusing the glass as colored in their program. And then the ultimate challenge will be to reuse laminated glass coming off a building. There's significant challenges with that. There's colored recovery going on, but a lot of stuff that's not colored gets shifted with the PVB. So we've seen very mixed waste fractions there that are just not processable to interlayers anymore. Logistical and network challenges, of course, but what's also important, and I want to bring to your attention, is sometimes people focus on recycled content. And they think, well, anything what you do here is great, makes perfect sense. But if we spend a lot of energy in collection and transport, and even worse, if we have to do a lot of processing to clean the materials up, that's energy. So you may be gaining in recycled content, but going down in embodied carbon, and that doesn't make sense to us, is something we want to avoid. So with that, we've come to the end of the presentation. Takeaways: PVB interlayers are an important part in the options to reduce embodied carbon in laminated glass. Make sure to use specific LCA values that are third-party verified. And if you have an interest in reducing the embodied carbon of your laminates, look at the PVB products that are fit, such as Soflex Light Carbon Clear, and then we have the documentation ready to plug it into the value chain. Want to learn more? Please stop by at our small stand here on the floor. Thank you.